Hello. Hi, how are you? Today's topic is ANCOVA Plus or ATI Model. We actually learned the ATI Model before, but today's topic is more focused on conceptual things about ATI. Alright, so Yij equals mu plus alpha j plus beta w xij minus mu x plus alpha beta, so this is multiplication, alpha beta j xij minus mu x plus eij. So this notation is ANOVA for ATI model. Okay, so we can convert this into regression notation. So Yij equals beta 0 plus beta 1 x1 plus covariate part beta 2 x2 plus beta 3 interaction parameter and x1 times x2. So multiplication between x and x2. So that is interaction, okay? And plus residual. Okay? This model includes all the terms from the ANCOVA model, interaction term between the covariate and group J in the population, which is multiplied by this centering vector, xij, individual scores, minus mu x, so mean of covariate x, so centered covariate score. Okay. The alpha times beta j interaction term tells us whether the slope for the covariate differs for each group. All right, so here, another way to write the model is more like a regression model with the same slopes for the covariate terms, but where the x-scores are not deviated from the mean. Okay, yes. So beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x1 times x2 plus eij. In the model, we do not have an estimate of grand mean mu. So grand mean, instead of grand mean mu, we use beta 0. This version of the model is closer to what is estimated by SPSS and presented in the parameter estimates output. We can compute the separate regression lines for each group using the parameter estimates from SPSS. So if you have multiple groups based upon parameter estimates output, you can make two different groups equation, two different equation for two groups, right? In this plot, covariate teacher happiness does not relate to the student achievement. So student achievement is dependent variable outcome. In the same way for schools in 3 locations. The slope for rural schools is much flatter than those for urban and suburban schools. So this dotted line is the rural school slope. And these two lines are urban and suburban. So if we just, average all of the urbanicity levels, it's gonna be much kind of, something between two. But once you watch the video 6C, you know how to generate interaction plot like this. So different slopes among different groups. Okay. So here, this model also suggests that there are no difference between urbanicity level. G10 urban is not statistically significant. So no difference between urbanicity levels in the dependent variable means when teacher happiness covariate is controlled. Teacher happiness as a covariate, this is statistically significant because it is smaller than alpha. And now the interaction between G10 urban and teacher happiness is statistically significant. So when your interaction effect is statistically significant, even though one of your main factors is not statistically significant, you still need to include this one if you have an interaction effect between two, okay? Always. So if you include your interaction in your model, regardless of the significance of the main effect, you need to include the main effect in the model all the time, okay? So p-value 0.008. This interaction term is statistically significant. So p-value on the G10 times teacher happiness line shows that we need to keep the interaction term. That is, we have a treatment by covariate interaction or ATI, aptitude treatment interaction. We now want to find out how the covariate relates to the outcome in the different groups. So you might wonder why people use the term treatment here, even though you don't have any treatment here, right? But just this is from the psychology discipline. So the psychologists have a lot of developed interventions so to improve the psychological problems. So they have a lot of treatments, or intervention, and then we bring the way how they do it, the method. We borrow the method. That's why we also borrow the terminology, the jargon, ATI, treatment, in this statistics class also. That's why. So G10 urban, yes, we know this is not a treatment or this is not an intervention. However, the technique is used. The technique that we use in this statistics class is also borrowed from psychology. And so the term, the label is also borrowed like this way. So just don't worry about whether or not we use, we do not use a treatment, but why do we use this terminology, this term? And don't worry about it, we just bring the method here. So even though the G10 urban is not a treatment, we still, borrow the technique from them. So that's why we keep calling this, categorical variable as the treatment, but actually it is not a treatment, right? Because this is one of the demographics, like location or areas or region, right? So, yeah. Conventionally, we just use the term treatment here, okay? All right, in the SPSS variable view, SPSS data format, you have the two tabs on the bottom, and then one is a data view, the other is a variable view, right? So once you click the variable view, you can find out the G10 is coded as 3 different categories. The values that are added in for schools in each of those locations are shown in the column label B. So column label B is this unstandardized coefficient, unstandardized slope coefficients. Okay, intercept 50.525 and G10 urban 1 is urban, right? So 0.791 and G10 urban 2 suburban and 0.681 and G10 urban 3 is 0. So this is a reference group. Rural schools are reference group, and teacher happiness 0.213. This is covariate. This is covariate for teacher happiness slope. And then these three are interaction effect, and urban times teacher happiness is 0.456, and suburban times teacher happiness is 0.323, and rural was plugged with 0, right? So 0 times teacher happiness becomes 0. Okay? The interaction terms are the deviation of the covariate slopes for the labeled groups from the teacher happiness slope for the omitted group. What is it? Rural schools. So number 1 group is urban, number 2 is suburban, number 3 is rural. So B labeled teacher happiness 0.213 is the value of the slope for rural schools. For the schools in urban, coded as 1 location, we would add to this, to the value to the rural. Okay, so the urban schools, the happiness slope is 0.213 plus 0.456 equals 0.669. So this is for urban schools teacher happiness slope, okay, x2, beta 2. For suburban schools, it is 0.213 plus 0.323. So here, 2.213 is rural schools covariate, and 0.323 here for suburban. You should add this one to this. So for the suburban covariate slope is 0.536. Anyway, using words for dummy variables names, the whole model can be written like this way. So how did you get this one? This is from here. Okay, you get that equation from this coefficient, the parameter estimate table. So with one general form, estimated regression line. And then for rural schools, we do not include terms involving urban or suburban. These appear only for urban or suburban schools. So once you plug dummy variable as 0 here, then you have rural schools regression equation. So urban, suburban, what is the reference group? Rural schools, right? So for the urban dummy variable, you plug 0 in this vector, and also you plug 0 in this variable, right? So it's removed, right? Cancel out. And this is nothing related to the canceling out thing. But here, urban, dummy variable. Here, suburban. Again, you plug 0 here, you plug 0 here. So these two terms are also removed, right? So what is the remainder? So y hat for ruler equals 50.525. Cancel, and plus 0.213 teacher happiness, and cancel. So the regression equation for rural schools equals y hat equals 50.525 plus 0.213 teacher happiness. So does this make sense? Here we use Xij, teacher happiness, in the model instead of a vowel label. We can take the model apart since the variables all involve dummy variables for urban or suburban schools. So since urban, so I just did it, right? So this is the remainder. This is the rural school. So now urban school. So for urban school is coded as 1. So once you plug 1, and here urban, you plug a 0 here because urban is a non-suburban. So you plug a 0 here. And here, teacher happiness, leave it alone. And urban times the teacher happiness. So you plug 1 here, and what the remainder is. The Xij is still here. And here, urban is a non-suburban. So you plug a 0 here, and it will be gone. So you have this equation now organized. So you use parentheses, and Xij is here, and this become new y-intercept. Okay, so y-intercept, this is new y-intercept plus new slope. So this equation is for urban school. Y hat equals 51.316 plus 0.669 Xij. Suburban school, we select the terms that have suburban in them plus the teacher happiness term. So suburban is, you become, for urban variable, suburban 0 here. Suburban, you plug 1. And leave it alone for teacher happiness term. And urban is 0 and 1. So likewise, suburban equation, regression equation become like this. So we have 3 different equation lines. So SPSS also uses ATI model to estimate marginal means. It does this by computing predicted values with the value of x equal to the mean of covariate. For instance, the mean on teacher happiness is 0.1372. We will substitute this value into each of the models and compute estimates for the 3 school locations. If we compute y hat values with x equals 0.1372, we get the estimated marginal means. So we have 3 different equation lines, and then you plug the covariate mean here. Then you get the y bar for urban school here, y bar for suburban school here, and y bar for urban school here. Okay. Finally, we can compare the means to those from the ANOVA model. This does not include the teacher happiness as a predictor. ANOVA has only categorical variable. Note also, standard errors for the means are all lower in the ATI model. So this is ANOVA model. So ANOVA, 1, 2, 3 groups. ANOVA mean. Okay. And this is ANCOVA plus or ATI model. So in this case, we have a common mean for covariate. So we have a common mean for Here, so we're gonna adjust the means of subgroups for Y using this controlling for all other vector, which is covariate. So here, these values are slightly different from these naive mean. And also grand mean here. So regardless of group mean, you average them and you have this one, this grand mean, and you average them, you have this grand mean. And marginal means are added to a plot for the ANOVA. They don't look too different. They are similar. Once you generate the SPSS plot, you can have estimated means, but you do not have a naive mean plot. So this is actually created by Excel file like that. Okay. We can also get particular predicted values using the equations. We did this before in the slide for multiple regression. So full model is this. Full model is this. 50.525 plus 0.791, urban plus 0.681, suburban, and covariate and interaction effect between urban and covariate plus interaction effect between suburban and covariate. So, for example, for the school, case number is this. For this school, the teacher happiness was coded as -4. Then you can plug this -4 in the equation line. Then you get this estimated Y. Full model again. In this full model, so for a urban school with teacher happiness is equal to 2. Then you plug 2 here. Then you have estimated Y score is like this. And for a rural school, teacher happiness for the school number is this. The teacher happiness was coded as 2. Then you plug teacher happiness 2, and rural is a reference group, so 0, 0. So here urban is 1. Here this is non-urban, so this is non-urban, so you plug 0. So know how to calculate this, right? Yeah, we did this before. Okay. The end. Wow. Okay, thank you very much and see you next time.